Hey guys, we're reviewing test one. So test one, I tried to do an overview on the first page. Sorry, I'm holding the phone and moving it this time. We did angles and their measure, right triangle trig, which we just did again, so you'll see it's very familiar. Trig functions of acute angles, trig functions of general angles in the unit circle. Let's see here. So at the beginning part, I did a little bullet point of everything we did in each section. We converted degrees to radians, radians to degrees. We defined coterminal angles. So coterminal just meant plus or minus a multiple of 360 degrees. We defined reference angles. That's the acute angle to the closest x-axis. We changed degrees to minutes, degrees, minutes, and seconds to decimal degrees, and vice versa. We calculated our arc length, our sector area, linear velocity, which are both of these. The distance, or r theta, would be like the arc length, right, over time. And we also did angular velocity, how quickly it's rotating. And this is linear velocity related to angular velocity. We have all of our trig relationships, our sine, cosine, tangent, cosecant, secant, cotangent. We have our quotient identities, which are sine over cosine, our cotangent, which is cosine over sine. We have our reciprocal identities. Remember, these came up again in test 3, so we've seen them more than once. Sine is the reciprocal of cosecant, cosine and secant, tangent and cotangent. Then we had our Pythagorean identities. This is the only one I really want you to memorize. Sine squared plus cosine squared equals 1. I divided through by sine squared to get 1 plus the cotangent squared equals cosecant squared. And I divided through by cosine squared to get tangent squared plus 1 equals secant squared. Then the complementary angles. Remember, if you have, I'm going to use this triangle as an example. If this angle is 30, this angle up here is always going to be 90 minus 30, or 60, right? Meaning the secant of 30, which is the square root of 3 over 2, is going to be the same thing as the cosecant of 90 minus 30, or the cosecant of 60. So our cosecant is opposite over, hypotenuse over opposite, so it's 2 over the square root of 3. So they're both equal to 2 over the square root of 3. That's all that means. We did our 45, 45, 90 triangles, our 30, 60, 90 triangles. We used a calculator, some application problems. We used reference angles and coterminal angles, because now we're going to have negative trig values, right? So now we can find the trig value of an angle anywhere on the xy plane for all 6 trig functions. We also know that in certain quadrants, certain trig functions are positive or negative, so we can figure out what quadrant our angles are in. Then finally, we did the unit circle. So the unit circle, remember, the biggest ones I want you to know are just the quadrant angles. It's a radius of 1, but our points turn out to be cosine comma sine. So here at 0, our cosine is 1, our sine is 0, our tangent, which is sine over cosine, is 0, but our cotangent's undefined. So remember, we get to graphs, that's why it's an asymptote there. We learned that trig functions are periodic. That just means they repeat every time we go around. So they repeat every 2 pi, except tangent and cotangent, it's pi. That there are even odd properties. So even is cosine and secant. I wrote something down here, like the cosine of negative pi over 2 is going to equal the cosine of pi over 2. But sine, however, is odd. So the sine of negative pi over 2 is -1. The sine of pi over 2 is 1. So remember, it's the negative value. And then we also had to do a little bit of domain and range. So we'll get there. I like those better with the graphs, but now we know the graphs. So if you remember it from the graphs, even better. Okay, we're going to keep continuing the trig functions, the review for test 1. And I'm pretty sure you're going to think it's not too terrible. Stay tuned.